like to thank G2. It's our sponsor. So if you wanted to, give me a second, sorry. If you wanted to speak with them, there are guys from it. There is the Petr Vávra. So if you wanted to speak about building the platform in their stack, so you can speak with him. The G2 also provides the free model of the simply managing the Kubernetes cluster in the VMware sphere, so you can speak with them about it. So, I also like to thank ShipMonk to provide us this amazing venue and also the refreshments. So please just make some applause for them. Please. Thank you. It will be short, I think. So, some QR codes. Like, maybe you know KubeCon is the biggest conference about the cloud in Europe. So next one will be in Paris. So you can sign it up there if you are not there, and you can also use the discount code. Is for 15% discount. The QR code is not for the discount code, so just make the photo. QR code is for the registration for the event. But if you follow us on the LinkedIn or you are joining the Slack, the codes are there. Yeah, this information are provided there. Okay, I will wait a minute. I still see some mobiles. There'll be more QR codes. Okay, so it seems it's done. Then I spoke about the KCD, like Kubernetes Community Days. It's the conference which I organized with my friends from Slovakia, and this year it will happen in Prague. It will be in June. So CFP are open, and also you can register there. So it's up to you. And online, I think online tickets are free till end of March. Then it will be paid. So another one. The Cloud Native Prague, there's another meetup in February. It will be in Microsoft. There will be a panel discussion about the platform engineering, so you can sign it up there. And last slide with QR codes. It's a Golang meetup. As I said, we have an organizer of the Golang here. Where is Láďa? There it is. So if you like Golang, so you can sign it up there. It's on the meetup.com. I think you can register there. It's also in the February. So. Yeah, and TerraMate will be there. Thanks. So, something about today. So there will be two speakers. First will be Martin Beránek. He will be speaking about migrating ingress controllers, the 6-month journey from Nginx to traffic. And second will be Tomáš Emmerich, and he will be speaking about the Selenium. So, if you have any questions for the speakers, so you can use Slido. So you can scan up this code, or just open the Slido and type it the CMP. You can also ask from the audience, but for the show, for some people who are scared, so you can just write the question there. So. And that's it from my side. I think that it was a lot of things. So I'd like to welcome the first speaker, Martin Beránek from the ShipMonk. So please some applause. And
thank you. Thank you very much. I need to reconnect, so there's going to be like silent break. Thank you, Mr. Ambassador. Almost there. Cool. No můžeš.
Sorry, I just forget to mention something. There's the food.
It's behind me, so it's really awkward to go there.
Yeah.
You can go around, like there is the doors, and you can just go around and reach from the other side.
Yeah.
That's what I do.
There's also toilets there.
Less awkward path to the toilets is over there. They are like the other one. You don't need to go around here.
Yeah, and also there's table where you can, for free, take some merch. It's from the KCDs and some vendors, so just take it if you want. So that's it, sorry.
No worries. Thanks for the introduction. My name is Martin. I am infrastructure lead, which is something like team lead for infra. And for the sake of this talk, I nickname myself as a traffic evangelist. It's a wonderful journey, so that's why I thought that we are going to share the experience, share the pain, the mishaps and the issues, because those are the ones you can really learn from. So let me just do the small introduction, what we are talking about, what we dealt with. So the history of Ingress setup here in ShipMonk. ShipMonk migrated from DigitalOcean droplets, in 2019 into the Kubernetes. Back then, we used fully native cloud way of AWS application load balancers, which also had some kind of small issues, like back then, additional latencies. Not sure if this is me or going to step away. Okay. And then we switched to network load balancers with backend made from Nginx, which then forwarded the content back to the backends full of PHP and all the other applications running there. It kind of worked. We had minor issues, as I was saying, with latencies, config maps where we kept the configuration for the Nginx. It wasn't really convenient, but back then you really didn't have that many options to try, and for the purpose which we were deploying, it was kind of all right. access logs got disabled pretty fast, especially during the high load, during the peaks and stuff. The cost was just too much. So in some cases we are kind of blind, but for the initial setup it was kind of all right. To be honest, Nginx, especially the community version, does not really offer any metrics. So once the access logs get disabled, as I was saying, you are pretty much blind. You can buy Nginx Plus. It's a superb product. I tested it for like a week or two. You can ask them. There's always some referral for the country you are in. And for the setup we have, I asked them how much would it cost. And they were saying something in between $2,000 to $4,000 a year. I asked my management, they said no. So we had to figure something else out. We had some issues during the high utilization and high connection count. Not sure if we can, like, the screen is kind of flipping on and off. I'm not sure if it's a problem. Not right now, you know. Okay. And then we had something which I call like upstream setup issue, which caused additional 500 trees error from the backends. It's kind of nice to explain it. There is a setup called service upstream, and if you set it to true, it will, instead of picking each pod, IP and port, use the services directly from Kubernetes. And it says in the documentation, this is from documentation, that it kind of helps with zero downtime deployment. Nice, you know, that's what you want. So we switch it on. And after a few months, we notice this ugly thing. This is actually from GitHub issue. Thanks, Narco, for the nice screenshot. So these lines, those are the backends. And you can see that if the service upstream is set to true, those are really not evenly used. If you switch it off, it starts to be used, you know, evenly the way you would like to. It's kind of bad, you know, because 500 trees are usually there in case the backend is not really accessible. So Nginx tries to give you something. So once you start to, I'm not going to report it. Once you start to have those 500 trees during the deployment and you just switch to service upstream true, you then can generate much more of those codes just because only a single backend is utilized over the others. So the horizontal pod autoscaler can't do really anything about it. It will just stick with the average statistics of overall load. And you are at the end generating much more fine-unit trees in the process. So switching it off kind of saved the day. That was it, and with that we kind of felt that that's enough, let's try something else. So we first summarized our requirements, what we really want to have. So we just wanted to use similar setup, no new custom CRDs, no service meshes, something which really works. We did not want to try anything fancy, you know, so let's just find something which is already here, and it was like proven over the time. The setup has to be similar on production and on devs. I have a slide on devs as well. It has to have at least some kind of metrics. If I maybe plug it on and off, maybe it will help, not sure. Works now, okay. So those metrics should be pushable to Datadog because we are not really using Prometheus on its own. And it has to be stable, which is, you know, really nice, but sometimes you just never know. A few words about our dev environments. There you might know why we are not really using the native way, the application load balancer from AWS. The thing is that each developer, each QA, whoever needs to, can deploy their own dev environment on their own. They can just go to the merge request and click on a play button. It will deploy everything for them, and those environments will be there for a few hours. Then they get suspended. They could be resurrected by redeploy. It's really complex, really hard, but you know, we are making it happen. Each of that environment has 8 ingresses overall. Each of that environment has over like 32 rules. So if you multiply it during the peak hours, we have like 50 environments running. So from the estimate I got, you would be paying something around $700 per month. So it's like way more than Nginx Plus. And that's the reason why we actually decided that, you know, we have to use something like Nginx traffic or whatever, rather than having AWS load balancer in there. So this was the plan. Well, the plan actually started and ended somewhere in the middle. Everything else was then solving some kind of issues and problems we had along the way. Don't really need to read it. I just put it there because it's long. So the idea was that we are going to, well, we have Cloudflare in front of everything. Then we have network load balancers. For each of the control, there's a different load balancer. So we can say that Cloudflare please forward, let's say, 10% of the traffic to Nginx, 90 to traffic, and switch it in between in case something will go horribly wrong, which of course did. So what actually took us so long is, you know, the presentation says it was like half-a-year journey. It's kind of a lot of problems, and I kind of choose just 4 of them because those are, I think, the most illustrative I can come up with. So the first one was a really easy one, TLS suites issue, and I kind of decided to rebrand it to partners are really old. If you ever work in fulfillment environment, your customers and clients are going to probably use some things like SAP, you know, and all of these warehouse software, which is not really from this century most of the time. And we received this report of ICM HTTP SSL error. It's just totally nothing, but we kind of guessed that since we migrated to something new, something different, we used the recommended TLS suites for the front end. So that might be an issue at the end. So we just had to go and downgraded our TLS suites. So it wasn't really fixed, you know, but at least we can work with our partners to the bright future. And maybe one day it will happen, you know. And I just don't want to know what they are deploying into their Java applications and so on. It's running, and they are like responsible for their, you know, security and stuff. So hopefully one day it will get much better. So it was fixed in 1 day. Wow, nice. So where are the rest of the half of a year? So the second issue and I named it eProto error in Node.js. And for that, hopefully the display is going to work. I'll be able to show you that there is something called proxy protocol v2, and you can set it up in your network load balancer in AWS. Not to really dig into the details because I do not really know them that well. For me, the proxy protocol v2 does the thing that it will just propagate the client information through the various proxy right into our backends. That's actually kind of necessary for us, so we felt, okay, it's a v2, it's modern, so better than v1, let's just switch it on and keep it that way. Just remember it for the future reference. So, we started to receive this error. It just says eProto and something with SSL, and that's it. It's from Node.js. And that's the only thing we knew. And at the end, I think it's like only thing we knew, we know even right now. So it wasn't really that easy to debug. It was happening in warehouses stations, which is like specific hardware, which has some sort of custom operating system running at a special hardware designated for running in harsh environment, in the warehouses, in the dust and everything. So, we just played the blame game, So it wasn't our problem in the first place. It was a problem of, SSL setup on those operating system, It wasn't us, definitely, TLS SSL suites, old, not our problem. Old operating system, for sure. That can be us, can be. We tried to replicate it. It actually helped. We managed to get the same version of packages, same version of Node, and it started to fail on our own machine as well. But the failing, the errors, they were like not really happening that often, like few of them every 1 hour. So you can kind of neglect it. You can put there some exponential backoff, retry, and it will kind of work. So then we felt, okay, so let's just try to replicate it with some different programming language. Maybe there's some kind of Node issue. So it did not work on Node. It was failing. But for Golang, it was working correctly. Those are the test cases. So we're like definitely sure that's not us. It's just, that's a Node problem. Let's ignore it. Let's ask developers to adjust the code, and let's move on. So we said, okay, that's done. It's like 80 days and fixed. A few days later, once we switched to traffic again, this is really annoying. I hope you have wonderful experience. Food is good, really. And I'm also waiting for the Cilium presentation as well, so we are on the same page. So a few days later, Robert reported an issue. Metabase is down. It worked for the half of the team, it worked for Rich, it worked for Tomáš. Actually, it also worked for me, so I totally ignore it. But Robert had something else to say. Also, half of the company was kind of upset because we couldn't reproduce it, so we kind of ignored it for a while. But it was an issue. So it turned out that this is actually the third issue from the caption on the slide earlier. That for some reasons, in some cases, traffic returns non-TLS content on TLS endpoint. So I just, took my Warshak session, started digging in. It took me a while because I opened Warshak, I think last time at the university. So it actually sent this 400 bad request. That's so bad, like what I'm doing wrong, because 400 is like a client error, it's not. It would be like 500, I would have said, oh, okay, we can fix something on backend of 400. I did nothing wrong, so what the hell? Even the fact that I was able to see this content on TLS endpoint, that's something really bad. So what we knew, every time we switched to traffic, like 100% of traffic to traffic, wow, that's hard to pronounce. Issue started at 4 p.m. Prague time and 9 a.m. Eastern time. Obviously, the biggest, most of the customers are actually United States, so it kind of makes sense. But 4 p.m. Prague time is just bad time for anything. Everybody's already packing, going home. So if you have like an error at 4 p.m., nobody's going to, resolve it. So we usually switched back everything to Nginx and just go home. Okay. Well, yeah, it shouldn't be issue with the load, right? Because at the beginning, we benchmark everything with K6, which is like a benchmarking tool. So, I have my doubts because again, it's not sure how annoying it is. I'm going to disconnect it and plug it in again. Not sure if I can do it. Can I plug it out in, because it's like flickering all the time. I know you haven't saw it because you never watched what I'm saying. They just don't care about you. It's a TV, it's not a projector. Thank you, Mr. Ambassador. I'm just going to continue. Okay. So what I was saying, yeah, we benchmark everything with K6, and it wasn't throwing us any issues, which is kind of weird, but okay, maybe it was an thing with the Golang and how they are actually handling the connections, how they are recycling them, and so on. So maybe we had to look somewhere differently. It wasn't happening where when we used only like 10% or 15% of the traffic. It only happened in during the times where we were like forwarding 100% of the traffic to traffic. So let's just find a way how to bomb it to start to talk. And it's not really that easy. If you write anything which will just start to send a lot of data to the backend, you actually have to force your favorite programming language to create a lot of connections and not to close them again. So for Golang, you just never close the body, which is something a surgeon would say. But in this case, it just does a lot of connections, which then can, be really bad for the operating system. So be prepared if you are going like to 10,000, 16,000, that operating system will kill the process during that time. But it's actually not really that fast. So if my wonderful main app was running, well, during the time, healthy backend was like going to thousands of connections without any issues, and unhealthy backend actually ended up in like 3,000, 4,000, and just said that backend send it non-TLS traffic on TLS endpoint. So at least the issue was replicatable. That's nice. It haven't really helped us before, but this time we felt kind of lucky. So we did not really know at the end anyway. So we tried to open a ticket to AWS. Bad idea. They just did not care. It's just traffic. So fix your stuff and move on. We opened a ticket to traffic partner. If you are wondering how much would it cost to have a partner for traffic, it's something in the region of Nginx Plus. So they're like saying, okay, you can like get us, and we can help you with that. Which in retrospect, after I show you what was the issue, would be a lot of, would be a really expensive mistake. But it's like thousands of dollars for somebody who will probably help you, but you are never sure, Then we said, okay, so let's just use the traffic native way. Let's just use egress route, which is their CRD for ingress routing. Felt kind of nice. It's like good written manifest. You can like do quite a lot of stuff with it. Did not really help at all. We tried different architectures, different versions of the help chart. Up and down, 10 versions down. It wasn't really solving anything. Scaling traffic, which you can actually do, but traffic does not really, you would have to set the threshold really low because like thousands connection for it is really nothing. So we pre-scaled to 100 traffics. It took a lot of, machine power to do the benchmark afterwards. Okay, we are going to try that. Poor little grabber. Okay. And then we opened an issue on GitHub, which was at the end kind of fruitful. So what was the solution? If you remembered correctly, I was talking about about Proxy v2. Once it was disabled, it was working. It's just one little checkbox. Amazing. I also have the day count, which it took us to figure that one out. 180 days, Nice. Thank you, management, for keeping us in the company. Other than that, we are doing a wonderful job, It was all right. the most funny part is that once we reported it, somebody actually fixed it. 2-3 weeks ago, it got fixed by Julians, and somebody actually provided a good reproducible case how to make it, how to see the issue again. It was written in case 6, so I don't know what we are doing in the first place. So it's fixed now, but we are just not too keen on updating because we're just going to wait until we are sure that this is really stable. That was the third issue, and the fourth issue, usual suspect traffic. And as you might expect, during the debugging, there are quite a lot of questions of, could it be traffic? Is this error related to the migration you are doing? Half a year of the same questions, We have to live through this. It wasn't really nice, but it's our job. Needless to say, people try to blame everything on traffic with 90% of accuracy, but those 10% when they were incorrect, that just hurt, it's just demeaning. What can I say? The only cure is that you have overall your stable setup, you work on it, you make it stable right before you deploy it into the production, which in our case was not really easy. This is actually like the circle we are all doing. It's just a normal thing you would do in deploying almost anything. You just evaluate multiple options you can use. For us, it was like traffic, Nginx Plus, and so on. Once you are like really sure that you have to deploy it and it's going to work correctly, you just deploy it into production into the like small portions of traffic, which we really did. And as I was saying, it wasn't really having any issues in 10% or 50% of traffic. It started to fail at 100%. So again, it was really hard to replicate at the end. We then evaluated, announced the final deployment, which then got postponed multiple times for the reason I explained. And at the end, we clean up everything. And if you applied it, it's just common sense. You can't make any mistake unless you are dealing with proxy protocol v2. So the reputation got obviously kind of broken. So that's why I've written like fixed in lying 8 days. And we kind of have to work on it in the future, earn our trust again. But still, I did this presentation somewhat similar before, so a lot of people kind of feel sad for us. That kind of helps at the end. So it was kind of good. So a review of what actually the migration brought us. It's still flickering, it sucks. For me, for us, the biggest week of the year is the peak, which is the week of the Black Friday. For the Nginx, last year we had some kind of issue and it caused us like 10 minutes of downtime during the peak. That's really critical. And for traffic, the issue wasn't really visible. As you can see at the request count, you wouldn't even notice that there was something happening during the time. So we are kind of happy that we can worry about some new, different issues than just load balancer, and you can like move on to something else. Even the sizing, I think I wrote in the annotation that now the balancing setup costs us something like 10% of the previous price. The thing is that for the devs, we actually deployed Nginx as a daemon set, so it was kind of expensive just because it was running. So now on devs we have just 2 pods with traffic, and that's it. On production it's kind of similar, just half of the size of the Nginx we used to have before. And even that is just overscaled a bit. We have Cloud Health, which actually has a nice recommendation dashboard, saying what should be the right size. And these are the stats from the past, I think 60 days. So we can even go lower. We can like provision much smaller setup on production. It'll still work. How can you watch it? It's still flickering. The Cilium lecture, like, it has to be really good, since you are waiting for it. Maybe it's not going to flicker, but I can't promise anything. So for us, this actually worked, and we call it a success, even though it took a while. Well, yeah, it worked. So in retrospect, the summary of requirements. We got rid of those ingress routes. We are still using normal ingresses. So if you are like used to ingresses from Nginx, there wasn't any change. We have the same setup on production and so also on devs, even though it could be done rather differently. But this actually works and it's all right. Team actually knows the stuff, so it works well. We have the metrics in Prometheus, which are then pushed into the Datadog, also success. And it's somewhat stable now, and hopefully in the future as well. So yeah, that was my talk. I hope I wasn't really that short. Before the questions, I have to say this, we are hiring, so if you're interested, just go and get this Docker image. There's like a challenge. You don't need to, apply for the job. It's just a challenge. So if you are like interested in the fun, just to try it out, you are really welcome to try it out. I think it's like, I think I wrote somewhere that if you are not pulling your hair, once you are solving it, you are the material we can talk with. So it shouldn't be that hard. Yeah. So. Yeah, that's all for me. So if you have any question, Mr. Ambassador, I think will deliver the microphone to you.
Okay.
Thank you.
Thanks. In the meantime, you can try to decrease your resolution, and it should help. But is there any question? So, okay.
First of all, thanks for the talk. What I'm curious about, have you had any expectation prior to actually moving the traffic that you will see in terms of like a memory consumption or some benefits that you didn't see using the Nginx? You already explained us, but like, what was the thing that we will have it with the traffic and you had it? Thank you.
Yeah, thanks for the question. Actually, like we just wanted to know what's going on, and with like a community Nginx, the metrics and all the monitoring you have is just a pretty basic. It's there, but it's not really like usable in sense that you can get like count of 500 error codes, 200s, and so on. So we are just having things like transfer bytes, which is, I don't know, I never use it. It's like metric for almost nothing. So that was one of the requirements, and it actually was really strong for us because developers were asking like, okay, so we deployed something and we are not really sure if it's good or bad, and only thing we are seeing is from Datadog and from the profiling, and so on. So is there something other than that? Is load balancer actually reporting something we are not seeing right now? And we had no solid answer. So for us, this was one of the biggest driver to switch to something else. And of course, like the team know-how was actually like one of the biggest reason, because all of us kind of knew how it works, because traffic is not really new. It's just I think it is here since like, I don't know, I do remember I was using it in 2019 as well. So we felt, okay, there's a mature option. It's nothing fancy, nothing like service mesh, so the transformation and our cover and support will be like reasonable. We are not endangering anything with something we are not really sure about. That's what we thought originally. Yeah. So yeah, those were the main reason, I believe. Yeah, I'm not sure if I'm. Yeah. Okay. Thanks.
We have a question on the Slido.
Nice.
It's Nginx Ingress controller or Ingress Nginx. Maybe it's about if it's the official vanilla Nginx by Kubernetes or by the F5. I think.
Like what we used, or?
Yeah, I think so. There's no other stuff in the question.
Like
so
if I would like to choose, which one would I choose? Or I think like F5 is actually working proactively on Nginx Plus. And don't get me wrong, I think it's like wonderful load balancer. You can like use it. It has the similar setup as normal Nginx, because they actually sell it as a product, as a normal application, web load balancing thingy you are kind of used to from the old times, and I think it's really good. Especially it was really nice back then, where you had like PHP backends, and you would like to have some kind of dashboards and so on. And they're actually like working on it, and it's still actively maintained. I think the biggest problem for us was the pricing, especially because we are deploying the Nginx controller as a daemon set. So in some cases there was like 50 replicas of the Nginx. So that's why I think the billing wasn't really convenient for us. But if you have a good use case, you know how to handle it, how to work with it, I would definitely use it. You know, it's still not, well, it's not cheap, but you are still paying for something which actually works. So it's nice. I'm not sure if I answered the question, but it was kind of weird though.
So any other question? No. Really no. Okay. So I have one. So when you think about it to move to the traffic, do you also consider any other solution?
Yeah, of course.
And why you choose the traffic?
Yeah, of course. We tried like multiple of those. For each of those, we did the benchmarks. We deployed like dev environment for each. So we were like kind of sure that it will work, or if we had to do like a lot of changes with it. But at the end, it came down to the like team know-how. We were still kind of worrying that if we would use something really fancy, current, and modern, we would be like endangering what we already have. And for us, the overall stability, now it sounds kind of funny, but the overall stability was the biggest factor we were kind of aiming at. So that's why I thought that, okay, let's just pick something which all of us knew for a really long time. We wouldn't hesitate with it, and we can just move on. So that's why traffic. Like most of the team members actually knew it before, so that's why we actually like prefer it. Also, it was kind of for free because it's open source. But it has its perks, you know. As I was saying, like we try to contact the traffic partners, and they also have their own price, and it's kind of reasonable. I said it kind of harshly, but I believe that if you would pay the price, they would really help us. You know, can you imagine those guys coming in, you know, just going through the architecture and then just flipping the switch off, you know? And then I would say to the management, I said, oh yeah, we paid those money, you know, it's there, it's running. Oh, amazing. What did they do actually? I don't want to say. Yeah, so that's it.
Okay, thanks. Be careful. Open source doesn't mean it's for free.
Yeah, it's true.
Okay, so if there is no other questions, so we have, so thanks, Martin.
Thank you.
So, and we have more time, I think 20 minutes before the next talk, so you can speak with the guys from ShipMonk or with the guys from the G2. So let's enjoy it and grab some food and drink. So. So guys, can you please take your seats? The second presentation will start, so. Thank you. So I'd like to welcome the second speaker, Tomáš Hamrich. So it's yours.
So, hello everyone. Cool. So let's begin. Whoop. Maybe not. Yeah, wrong screen. Okie dokie. So, what's this talk all about? So, some sort of introduction for myself. My name is Tomáš Hamrich, as you already heard from Zdeněk. I work at Prussia Research Company as a DevOps engineer, I think. And this talk will be about Cilium and all the things that it is capable of, and not all of them, because it will be like too much long for a presentation. But I will cover the fields where I think where the technology really shines, and I will try to cover fields that you may need or may want in your Kubernetes setups to use. So, first of all, what is a CNI? Anyone knows? Cool. Awesome, thank you very much. And what is it for? Awesome, thank you very much. So you already know all of that. Basically you have your Kubernetes clusters, you have bunch of resources deployed in there, and you need some way for your services to communicate with each other. So that's what an CNI is for. So what are the commonly used ones? Which CNI do you use, if you already use? And which ones? Okay. And more cloud native ones? If any. Correct, thank you very much. Yeah. Freaking labels, yeah. Okay. As you see from the screenshot that I took from the CNC landscape, there are a few of them. Besides the branded ones, I think from the small research I had, the most commonly used ones for sometimes are Calico, WeaveNet from Weaveworks, and Flannel, which is up there, little squares. So most of you, I think, if you don't know what CNI you use, you probably have Calico in there, because it's like the well-established standard for quite some time, and a lot of providers use this CNI by default in their managed Kubernetes clusters. So I'll try to cover some like basic features of the most commonly used ones, besides branded ones. Flannel was one of the first, so to say, CNI plugins. It is very approachable, it's very easy to use, very easy to set up, and was widely used back then. But it has, for today's scope, it has few pitfalls. One of them that I consider being really huge is that it has no support for network policies. The Calico one is based on IP table rules, which I'll speak about for some time, but wait for it. They implemented eBPF also, but so to say recently. And compared to Cilium, which is on the right side, the implementation is a bit different, mostly on the receive path. The Calico plugin, in contrast to Cilium, is owned by a private company, so it's not, so to say, like a community resourced as Cilium, but it's on the market for some time, quite long, so it's like battle tested and well established, so you can rely on it to work with like high performance. It's reliable, and compared to other stuff, it has a really low latencies. And added to Flannel, the Calico has support for network policies, as you may already use some of them. But as it's relying on IP tables in the back, most of these network policies are like aware of the IP addresses, subnets, routes, and stuff like that, so no Kubernetes objects, so to speak. And in the end, the Cilium, which will cover all of this talk. Cilium is a CNI which is based on eBPF right away. I'll describe that feature later. The tool itself is owned or was donated to CNCF, and it's already a graduated project, so you can like rely on it for some time, because it's community resourced, and that's a peace of mind that a lot of companies here. When Cilium started as a CNI plugin, which was like 8 years almost, it was like hugely and fastly adopted by major providers. It has extensive feature set, and their development is like really fast. The community is agile, and the tool itself is developing like with great velocity. And in contrast to Calico, Cilium can work not only on layer 3 or 4, but also on layer 7. I will cover that later in more detail. The most killer feature I think Cilium offers is the identity-based security. So Cilium is aware of Kubernetes objects when you have them. So you can specify your policies and stuff like that based on your like bots and namespaces and services and stuff like that, and Cilium knows what objects are you talking about. Okay, next. So how a CNI will look like. Yeah, you can see that, and you already know that. Sure. Okay, the network overhead. I spoke about IP tables with Calico, and I briefly spoke about the eBPF, which I'll cover in more detail later. But as you can maybe see from the picture, when covering the network communication in your node, when dealing with IP tables, the network park is much longer, and there's much more overhead and much more like much work, much context shifts compared to the eBPF solution, as the technology that sits inside the kernel of the operating system itself. So when you switch from IP tables to eBPF, You have less overhead on a network side and less context switching. So the killer features of Cilium. The first and foremost, it can understand and it can filter network traffic, being it layer 7 protocols like HTTP, gRPC, but it can understand also like specific protocols like Kafka or Cassandra and stuff like that. Network policies understand the application level concept. As the technology sits in the kernel, that the technology that's behind the Cilium, it has a huge visibility into the network, basically up to the TCP packet level. And the eBPF technology that's basically behind the Cilium is right now supported by all Linux distros, pretty much all of them, I think. So you can like safely choose this technology regardless of what distro you use on your nodes. And the eBPF technology was like initially developed by some of the guys that already worked on implementing Cilium itself. So the developers had a huge and deep understanding of eBPF when they were developing Cilium. So they had pretty much good expertise when developing this tool. So let's take a step back and I'll talk about what a Cilium really is. So first of all, it's an open source and cloud native piece of software. It provides network connectivity, it can secure it, it can observe it, and it's currently the most mature and most advanced CNI that CNCF offers that you can use without paying. How it all started. The first commit to the repository was done by the CEO, CTO, or the owner of the company Isovalent, Tomáš Graf, on December 2015. A few years it was like pretty unnoticed, the tool, but the last 3 or 4 years it's basically skyrocketed, and it was supported by the community. Today, the Cilium has been picked by all major vendors to their offerings. So now you can choose your SaaS solution for Kubernetes with this networking plugin. So you can try it out even with when managed Kubernetes. Okay, Cilium itself could be considered as a family of products or family of tools because they have multiple of them. So we are not just talking about the container network interface, but more plugins that they offer. First of all, it's Cilium. The other very interesting tool is called Hubble. The youngest member of the family is Tetragon, and all these technologies are backed up by eBPF. So the CNI itself, Cilium, it can provide you like the network connectivity, it can do like load balancing and all the stuff you basically expect from a networking plugin. It can operate on L3, L4, and on the application level. It already has like hundreds of big adapters, being it like Google, Yahoo, and New York Times and stuff like that, and using the eBPF as its core strength. The Hubble. Hubble is their like observability tool, so to say. Basically, when you have a technology that sits inside the kernel, you have visibility down to the level of a TCP packet. And with Hubble, you can observe what is happening, being it your pod communication, being it your service communication, being it like all the packets that through for your network flow. You can not just observe, but you can even troubleshoot, visualize, and you can set up your network policies accordingly. And it has GUI tool also. So that's like a screenshot of how it looks like. This south two parts are took from the GUI of the Hubble. So you can see your like pods and all these nice likely unseeable arrows which like describe the way of communication, the protocol that is used, the paths that are allowed by the endpoint and stuff like that. And this is like the result of some HTTP request and the way you can observe the data flow with the CLI tool. Okie dokie. Tetragon, as I already told you, it's the youngest member of the family. It's just a few months they released their 1.0 version. It's quite young, but again, like a quickly developing tool. The tool is designed to act upon security significant events. You can enforce your policies when, I don't know, you have like some suspicious I/O activity or suspicious network file access, or some like suspicious system calls happen, and you can act accordingly with the Tetragon. Or even when some process is executed which should not be. And in the end, the little B that I already told about, eBPF, that's the core technology of all the tools that Cilium family offers. And you can like imagine it like, yeah, you all know web browsers and you all know JavaScript, yeah? It's basically an equivalent for the kernel. So you can imagine you can plug your small programs that are hooked on like system calls in kernel, and you can like trigger with a system event some program that is loaded into the kernel. So what it means for you, if you have like your container or application and stuff like that, you don't need to change anything, because this tool sees like very deep into the container down to the kernel of the operating system, which is running on. So you already see all the data flow packets and stuff like that right out of the box. Okay, there was just some like basic stuff, and if you want more, Cilium offers the Q-proxy replacement, which is called the BP filter. So everyone not already using Cilium probably use Q-proxy, which in the backend relies on IP tables, which we all know are slow in the end. When you have like a huge number of network policies, they are like evaluated like line by line, and if you have like a huge number of policies, that's basically your bottleneck. And with eBPF, you have it like in a hash map, so it's executed like really fast. Okay, next we have mutual authentication, which you would probably expect when we are talking about the kernel level. if you want to switch on the MTLS with between your ports, it's like the 2 lines of YAML, so it's pretty doable, I think. Cilium offers load balancer, transparent encryption with IPsec or WireGuard technology, whichever you like or choose. They offer service mesh, cluster mesh. It can use like IPv4, IPv6, or even a combination of them. Some more creepy protocols like SCTP or multicast or stuff like that, which may some like telephone operators or stuff like that may use. It can simultaneously handle multiple streams of data, and it supports like some advanced PGP features. Okay, why do we need like another tool? What is the reason why the Cilium like exists today? Yeah, Kubernetes is like not complicated, and we all know what's happening inside, right? Yeah, say no one ever. Yeah, sure. And Kubernetes is secure out of box. Yeah, said no one ever. Okay, what are the common challenges that we face today? First of all, how do I tell which service is communicating to like other service? How can I like enforce some rules that my service A can communicate only to service B and not to like service C or something similar? And how do I even put like security into this place? How do I observe it? Yeah, do you know what we can use for that? Yeah. And service mesh. Yeah, that's all the answer. Yeah. What's the problem here? We already have service mesh. We have Istio, Linkerd, Kuma, stuff like that. They are already on the market for some time. Where's the catch with all the service meshes? Yeah, thank you very much. Sidecars, we all love them or we all hate them. They have some space and they can eat up all our money. Yeah, problems that sidecar causes are like extra latency. You have like longer network communication, so it took some time. They can be pretty complex. Most significant con is they eat up like pretty much all of your resources you have. Because imagine that every single pod you have deployed in your cluster has its own sidecar. So it's just basically doubles your cost, like almost for no reason. There are some race conditions where regarding startup and shutdowns with these sidecar proxies, and they can cause some delays on the startup time because pod startup will wait until the proxy is ready, and and the other way around. Okay, let's dig into the network path with the sidecar. So we have application. It crawls back through the networking stuff and reach the proxy, leaves the proxy, leaves the virtual Ethernet device, and down to the host system through the whole networking stack. And when we don't use the sidecar and supplement with eBPF, we have the application communicating through socket directly with the virtual Ethernet device and to the host machine. When we are talking about the L3 and L4, is the left one, and with L7 right now, because the kernel is not aware of the layer 7 connectivity, we are stuck with the using of the envoy proxy, like for now. Okay, there's some like controversy in the world right now regarding these all sidecars. In the image before, the envoy proxy you noticed was used just for the layer 7 because we don't have that technology in the kernel yet that we are aware of the application layer. So you need to have a proxy there to have like some observability and stuff like that. Cilium uses its own envoy config to configure these envoy listeners, so you can specify your all like path rewrites and stuff like that on routing. The controversy here is that when you have like the standard layout with say like Istio, you have sidecar basically with every pod that you have, but with Cilium you have this proxy sidecar only once per node. So that's kind of different setup. It has its own like pros, but it also has some like drawbacks. So if you have like two services that are communicating to each other on the same node, why do you need to have two proxies for them? You don't. You are wasting your resources. But there are some cases you may want to like implement more security and not to have like many pods communicating through like one proxy. You are probably you have a much harder time troubleshooting your communication because you cannot isolate it that much when you have like all of your stuff communicating through one proxy. And if you have just one proxy on a node, it could become a spot, because if that proxy is down, then you have a problem. And then is the another one. When we are talking about the eBPF, we are at the kernel, and this proxy is in the user namespace. So you are like the troubleshooting is like vyšší dívčí, bych řekl. I don't know how to say it in English. And with the proxy on the nodes, you can encounter like the noisy neighbor behaviors. Okay, let's take one step back and talk about the reasons why service mesh exist. Developers need basically everything from us. The application needs to communicate to like its other parts. That's like natural. Most of the times you have like multiple programming languages. They may not have like all the libraries, so they cannot talk to each other. So that was the initial reason why the communication was done through the proxy. So it was like that they don't have to be like the compatible languages because they are communicating through proxy. Developers wanted like canary rollouts and like circuit breaking, apply some rate limiting and stuff like all the service meshes can already do. All of this stuff could be solved by sidecar, but again, you have sidecar for every single pod that you have in your Kubernetes cluster. Okay, so that's all nice. It can work with the proxy, but it only works until you receive the bill. So there must be a better way, yeah, you say. eBPF, as we already told about. Cilium has its own implementation of a service mesh. It covers all the observability fields, like it has its own ingress, it provides load balancing, it can rewrite paths, it load balances services and stuff like that. As I told, it is identity based, so you can use the Kubernetes identities and you don't need to have like the rules for your IP addresses and subnet and stuff like that, which is like unmanageable. There's one great thing that's missing, and it's the MTLS on layer 7, which is currently on beta, and right now only working with a SPIFFE identity. But there are some ongoing effort, and even there's an effort to bring this MTLS authentication down into the kernel, but I think we are not there yet for some time. So what's the challenge with MTLS? And what's the way what a Cilium is doing like differently than every other provider? The thing is that Cilium separated the authentication and the encryption part. So the proxy initially was like designed to work with it only for TCP, but when you separate those authentication and encryption part, you can support protocols like UDP, SCTP, or multicast, which some companies may consider useful. Cilium already had like the strong network layer encryption using IPsec or WireGuard, whichever you choose. But what about the L7 again? How do we get the certificate injected into the kernel and authenticate? Well, we cannot just right now, only with the proxy. Okay, the reason why the Cilium is more than just a service mesh, the important thing is that it really understands the flow of the traffic you have inside the cluster. You can enforce policies, being it with Cilium or with Tetragon. You can write some like policies for your Cassandra or your Kafka traffic. So I don't know, you cannot like send some data to some topic. It understands the Kafka traffic itself. It works in kernel, which in the end means that it's fast in most cases, like blazing fast. You can explore the traffic you have inside between like your containers down to the TCP level. It's similar to the tab feature of Linkerd, but you can observe at a much lower level. And the important feature, you can combine Cilium CNI with existing service meshes. So if you use Istio or Linkerd, you can combine it. So it looks like eBPF is the jack of all trades, and you can use it for everything, and everything is gonna shine and be awesome. Well, not really. The technology itself is like great, and it has like very bright future, I think. And you can use it for XDP when you want to examine your raw packets as they like flow through your system, and then you can decide what to do with them. It's great for connection time load balancing, but where it does not really shine that well, or it's just expensive, is when you have like packet by packet processing. That means that if you like decrypt and then re-encrypt the encrypted flows, so it needs to build a structure and do the lookup for the every packet, which is like CPU heavy and intensive, and then your nodes will eat you alive. Okay, some recapitulation in the end. So what's the pros and cons? Cilium, it's available out of the box with many of the providers, like GKE has its like V2 or the Antas. AWS has also its solution, and I think the Azure also has it. It uses eBPF, which is so like very promising. It has strong engines for enforcing policies. In your cluster, it is aware of the Kubernetes identities, so you can get rid of the IP rules. And it has a great integration with Prometheus and all the Grafana stack. So you have like nice visualizations from Hubble about your data flow. And it is really active and fast-paced project. And some pitfalls. Setup can be a bit finicky. I mean, yeah, you can have it out of box when you have a like managed solution. But if you already have a Kubernetes cluster and don't want to have a new one, you may be out of luck. But yeah, it is doable. But some providers don't let you change your CNI, or yeah, you can run like 2 CNIs at the same time, but it may involve some downtime or some errors and some mistakes that you will not be able to recover from. So basically do not suggest that. The Hubble UI, as you saw before, is a bit dated and it's not that fast, so to say, but the CLI tool is great. The Hubble GUI is great for like observing your data flow, and if you want like the ClickOps stuff or the networking policies, it's great when you like beginning to dig into, but then CLI and yeah, creepy word. All of that's in Grafana. And yeah, some features not there yet. The MTL is on the layer 7, as I already told you. So if you wanna dig into, yeah, read the documentation. That's the greatest advice I can give you. They have labs which are free, and they're awesome. Try them out. There are lots of them. They are like providing, I think there's called like the career paths. So if you are like developer, if you are a SecOps engineer, if you are, I don't know, security specialist, they can pick the correct labs regarding your areas of focus. And in the end, when you have all of them, you have like this nice island with all these checkboxes, which is very rewarding. It's like collecting Pokemons. Yeah, some of the labs are really like trivial, easy, and very approachable. And some of them require more work, but totally worth it. Okay, when the documentation doesn't help you, read it again, because the information is already in there. When this not work, you can reach the community on their Slack. They have like the weekly live stream on YouTube, which is called Eco. And every week they are covering some small features. So this is like really approachable and really easy to digest. Not that much information coming. And if you ask on their Slack, the community is very supportive. So I encourage you to try it out. Okay, that's about me. I already told you my name. There's some contact if you want to reach me out, or just like grab a beer with me. Okay, that's all from my side. So here are your questions.
It was nice promo for selling the Selenium. You should work for them.
Really?
But not right now.
Okay.
So, is there any question? Okay, so we can start.
So hi, so you mentioned that the Cilium is looking into the containers in some way or another. Is there any reason it wouldn't work with VM-based containerization, so Kata containers or something like that?
No.
Awesome.
I have actually a comment and then a question because I need to make this clear, I suppose. I am quite skeptical, I guess we all are, if anything goes out from the container. So maybe I didn't get it right because eBPF can access all the way down the kernel from the container. So it doesn't there is no any security concern there. Is everything's okay?
Yes.
Well, it's all on the side of the container host. You're in control as the operator. So I would say there's no concern.
Yeah, thank you very much for
my
the
question,
much clearer explanation.
have you ever broken it? Long version. In the past, there was a Juniper Open Contrail, which compiled a big monolithic kernel module called vRouter, which magically made all routing, tunneling, and observability happen. I dismissed that as absolutely undebuggable. Because it was open source, but nobody was ever expected to read the code, probably. In here, it is a bit more modular with eBPF. You're injecting some bytecode into the kernel, into several hooked places. But anyway, as a network engineer, I want to have some routing tables, Mac learning, and so on. I can do that even with Open vSwitch. A bit rewriting, all right, I can adapt. But this is alien.
Yes.
I really want to see from anybody a lecture about how to break it and fix it again.
Yeah, I can confirm that debugging can be really challenging, so to speak. But the Hubble really helps. It's a great tool. Yeah, if you have Hubble, it's optional. Yeah. Okay, didn't know that. Okay, thanks for the info. Such a pitfall.
Another question? Just check the Slido if there's something. So Tom, I have one question.
Go
So
ahead.
what was the biggest setup you tried to use the Selenium? I mean, of course, production one.
Yeah, like this one, 0. Yeah, I set up at my machine Kubernetes clusters, and I basically done through all the labs they have, read all the resources, I think, but I have not used it in production or anywhere. Yeah, I use it at a AWS cloud provider, so to try it out, but not like the production level.
Okay, I think we can make another talk in 1 year and talk it next time.
Sure.
So he will have space this year to implement it in the production. So we will see.
Yeah, and I'm looking forward to it. Yeah.
So
No, I guess I can help with the scale. I've seen companies run it at 1,000 to 4,000 node clusters easily. Other stuff started falling apart before Cilium, so.
Yeah, but not with my hands.
we have question on Slido. Is Selenium made sure for migration from ETO service mesh? Can it do it GWT out, e.g. Cognito? Which ingress would you suggest to fill the possible gaps?
Yeah,
Okay,
yeah, yeah.
okay,
I thought I grab it. Not sure about the support for the Cognito and the WSNG JVT tokens. Yeah. But yeah, mm, it's a hard one. Right now, I think you cannot like easily migrate from Istio to Cilium without like breaking all of your stuff. You can like complement Istio with a Cilium CNI to have like greater observability, but you cannot simply replace it right now. Also, yeah, Istio is like made to be used with its own like ingress gateway, which also like helps with the layer 7 authentication and stuff like that. So it's like a nice ecosystem that works on itself. But if you like try to break it with some other stuff, it can go terribly wrong. So yeah, I hope that answers the question.
Any other question? If not, I just wanted to mention that Cilium was, I'm not sure if you know it, but Cilium was acquired by, I think, Cisco. So, is the one, sorry?
Yeah, is the one, is the company.
Yeah, yeah, sure. I mean, just product, but. So I think that we will see it maybe in the coming future, a lot of changes. So. But it's one of the most famous CNCF tool these days. So maybe if you are going to KubeCon, you will see there a lot of talks about it. So if it's all, so thank you. Thank you, Tomáš. And don't leave, just start the networking part. So we can speak about it if you want. So have fun.